uploading videos, I think. Yeah, we are uploading videos to a YouTube channel so people can watch the lectures later if they want. Bear with us as I learn how that works. But the botany lectures are already uploaded. So does anyone have any kind of class questions? I know some of you have questions about your mentors. If you've reached out to me specifically, I'll talk to you today about that. Otherwise, just bear with people and know that this does actually go through the end of April, and you will get your mentor checklist done. It's just sometimes you want it done right now. Yeah, that's all I know.
Can I put that extension really flat on the floor so you don't kill them?
You can try. It's curled up all the time, so it really likes to curl up.
Yeah, I see what you're saying. Well,
I'll be like your objective. Okay, so we're just going to dive in today. And if at any point you have any questions, just please stop me. Just to give you a little bit of faith in what we're about to go through, my undergrad research was actually all in beetles, specifically dung beetles. The kind that cool dung down, not the kind that cool balls. I think they get all the press. But so, this is actually one of the lectures that I think that on very short notice, it's not going to be as rough. But do pardon me looking down the slides. So today we have a number of learning objectives. First, we're really going to be starting with kind of an overview and appreciation of arthropod and insect biodiversity, just to kind of give you an idea of evolutionarily kind of where these guys fit and a little bit of back history to that. We're going to work through understanding basic insect anatomy and understanding insect life cycles and development patterns. This is really, really important, especially from a pest management perspective. You kind of have to know how something develops, what it's going through at different stages to be able to target it kind of using a number of different strategies. And that's something that we'll be really kind of touching on very lightly throughout the course today, is the idea of integrated pest management. So it's this idea that you don't just like swoop in at the last minute and spray it out with a bunch of nasty chemicals, but you kind of like, which, you know, there's a time and a place for that, like sometimes it comes to that. I know, I'm sorry, not if there are bees involved. Yeah, exactly. There's a lot of steps you can take before you ever get there to kind of try and manage pest populations. And some of the things you might even think are pests are just not. We'll be distinguishing between different insect mouthparts and feeding patterns. This is really important to know and understand so that when you look at your beloved plant that is just going to pieces, that you actually understand probably what it was and you can come up with the right culprit. Sometimes you'll see an insect sitting right next to the damage, but if you kind of knew what the damage was and what the insect was, you know he was innocent. And this goes along with recognizing the types of damage insects can do to plants at different life stages. And a lot of times insects at different life stages will do totally different types of damage. Or insects that have done damage at one life stage will just be wonderful at other life stages. Think butterflies and caterpillars. And also we'll be differentiating between signs and symptoms for insect identification. This is, signs and symptoms are actually different, and they're important when you think about how to identify insects, and especially if you were to send a sample over to the plant disease and insect clinic, they're going to ask you for different signs versus symptoms, and we'll learn how to kind of tell those apart. And so Matt Bertone, who's supposed to be here today, is one of our entomologists over at the plant disease and insect clinic. So I know he also really values that you know how to make this distinction, because it makes his life a lot easier. And then finally, we'll be recognizing some of the major groups of insects and related arthropods. This set of slides will actually come from a different presentation, so we'll take a quick stretch break and switch over to that one when it's time. Those slides are kind of an abridged form of the ones that I posted earlier in the week that were Matt Bertone's slides. His were pretty exhaustive. I took it down just a notch because I thought it was fun to go through, but I could see some people's eyes kind of glazed over in that process. So to start, what are insects? So this is kind of an interesting idea, actually, and it's something that you kind of go over in intro-level entomology. But if you think about, sorry, some of these are kind of hard to see, but if you think about kind of the various creepy crawlies that you might be used to in terms of centipedes and millipedes that have really a large number of body segments, insects are kind of this interesting thing where if you were to put them on, so I hate the idea of an evolutionary hierarchy. It's not accurate. Everything has been evolving the same amount of time if it's still alive. You know, they're not things that are more evolved. But if we were to like use that construct for a minute, if you think about some of these really, really multi-segmented, multi-legged species. And then you were to think about insects. What insects are is they're basically kind of an evolution from that, where they've reduced the number of segments. And often, like, if you think about insect heads, you have different types of mandibles, you have different segments, you have portions that have eyes, you have portions. It's almost as if you were to take a multi-segmented head and compress it back down. So insects are kind of just really interesting because they are clearly very, very related to these other organisms, but they've really taken the body form, simplified it, compressed things onto single segments, and been able to just kind of like explode. And so when we think about where the arthropods more broadly are situated, sorry, I have to step in front of this. So they're sister, and when I say sister, I mean they're most closely related to some of the different worms and different kind of weird, creepy crawlies you'll find in the dirt, to put it very frankly. And it's actually, they're not that far back from what would give rise to humans, right? So we are more closely related to insects than to, say, jellyfish, which is just kind of cool, which makes sense, because it was like critters crawled out of the ocean, took over land, and then that's kind of the lineage that we all are from. I got my evolution. I can talk about that all day. So sorry. So in terms of insect diversity, most of the planet is insects. That's just the truth of it. So you'll see here that insects, in terms of biodiversity, so this is the number of different types of species. Insects take up all this. Mammals are this tiny, tiny, tiny thing right here, right? And so it's really easy for us to get fixated on things like dogs and elephants and kind of these big things that we can see, but in terms of species, it's insects, and there's so many that we don't even know about. And I mean, I would have to look it up, but you always hear these crazy facts, like if you were able to like weigh all the ants on the planet in one go, it would just be terrifying. So the scientific number. So there's 6 to 10 million species of insects, and only 1 million of those are described. So when we talk about especially things like biodiversity and loss of biodiversity, a lot of where we're seeing as insects, and it's things that we don't even know what function they play in the ecosystem or what's happening to them. And as you can tell, beetles they're holding it down, right? 400,000 plus of those species are beetles. And so that is a group that is just kind of amazing in its biodiversity, amazing in the ability it has to take over different environments and to really adapt and thrive. So to put that in perspective, there's only 400,000 species of plants. So there are as many plants as there are beetles. And even 25,000 plus of those are orchids. So they're kind of like the plants, beetles, right? And again, only 4,000 species of mammals, like a lot of which are just bats, which is really interesting. I thought that was a fun fact when I found it. So in terms of, again, like I just really want to impress upon you kind of the roles that insects can play, and you can just imagine that they're in so many different ecosystems, they fill so many different niches, and it's really easy for us to just kind of see them and eat, but they're doing something very important. And that's why you want to be careful about your terrifying chemicals, because you never know what you're hitting that's off target. And less than 1% of insects are considered pests. So the vast majority of these guys are neutral, if not friendly. They're helping you in your garden, they're performing all sorts of vital tasks. And these are just kind of a smattering of those. So they improve soil, provide food, they can be pest predators. So that's one of the things you think about ladybugs, you think about some of your assassin bugs. They are great. They are a very good sign, even if some of them are a little bit terrifying looking. We have pollinators, obviously. Social bees get a lot of press for pollination, but we have a lot of other non-social or even just non-bees that are pollinators, especially flies are big pollinators for certain things. They are producers, so bees and honey, and they're also just beautiful. One of the things, especially when you think about improving soil, is so obviously the worm is not an insect, but we're kind of doing this kind of insects and garden category. So if you think a lot about worms, we think of worm castings, but if you think about a lot of the other burrowing insects, what they do that's really useful is they're burrowing through the soil, they're creating air pockets, and like Charlotte mentioned last week, when the plant's roots are growing through the soil, they're not actually growing through the soil itself, they're growing through the air. And so anything we can do to kind of aerate the soil and to get more space for water and for air into super helpful, and it's a lot of our burrowing insects that kind of do the real lion's share of that work. So just as a kind of a primer, well, what is an insect? So that's great, because we are going to talk about worms, we're going to talk about mites, not insects, right? To be an insect, you need, and this is where I talked about the kind of the reduction of body parts. You need a head, this might not actually work, whatever. You need a head, a thorax, this middle section, and an abdomen, which is the last section. And so this is where you would see on a lot of other arthropods, if you can see there's almost like a little line right here, that would have been multiple segments in a lot of other arthropods. In the insects, it's all been kind of reduced down to the central structure. You're going to have 3 pairs of legs. Don't be fooled by caterpillars. These don't count as legs. If it's gummy and a little bit weird, it's not a leg. It's got to be an actual kind of hard structure. And so this is something that always used to just blow my mind. And also you'll see some insects up here like this stink bug that it doesn't, you can't see those clear segments here, right? Like you can't see the abdomen and the thorax clearly. But if you were to pull back these wing covers, you would be able to still distinguish them back out. And so one of the kind of the most diagnostic features you can be looking for is that 3 pairs of legs, right? Because if you look at this stink bug and you're like, I just don't know. But he's got 6 legs. Air on the side of an insect, if you see 6 legs, that's very, very diagnostic. Other just kind of random fun facts about insects that were not included on this slide. So we have circulatory systems where, right, your blood runs through veins. Insects are just kind of a hard exoskeleton, which we'll talk about more in a minute, and like a tub of goo called hemolymph. It's insect blood, and the organs are then suspended in that hemolymph. Also, we have lungs, right? So we breathe in air, and it's in our lungs, and that's how the oxygen gets back out. Insects are small enough that instead of having kind of that sort of system where you have to have these centralized organs that then spread the air back out, they just have spiracles, which are holes into the body, and air can kind of diffuse passively throughout the hemolymph, which is their blood. They often have multiple brains in terms of like they'll have a major set of ganglia right kind of where you would expect, somewhere in the head, but then they'll have kind of supporting ones throughout the body. These are just my insect fun facts, in case you're into that sort of thing. And also, you'll have different types of eyes on different insects, where you'll have on, a lot of things like this winged ant, you'll have these kind of nice complex eyes, like, those finders you could look through where you can see a fly's perspective, and it's that sort of ripply thing. But you can also have sort of simpler eyes that are just really good at sensing light and dark. And so just depending on what they need, this is the thing about having, 6 to 10 million species. There's a lot of solutions for a lot of different problems, and they have a lot of different structures kind of in support. But again, 3 body segments, 6 legs, and a pair of antennae.
Do they have spiracles in the head, or does the mouth actually do some function?
I always see the diagrams of spiracles as mainly around the body.
That's what I've seen too, so I'm wondering.
But I'm not sure.
Okay.
Yeah, it's a good question, right? I mean, it's a good question. I've always seen that, really the air exchange is through that, and I think the mouth is more of just a eating. Yeah.
Because at some point, I can't remember whether it was in the book or whether it was somewhere else I read that the spiracles actually connect to a central trachea.
Right.
Which,
they kind of can move up and, yeah.
so there is a sort of channel.
Yeah, there's a channel, for sure. There's a way of moving the air through. They just don't have sort of the specialized, there are doctors and everything, so it's kind of scary to me, but the alveoli, where we actually have that exchange and then it has to move through the body after it does that. Sorry if I butchered that. I think it's roughly right. Yeah, that was one of my problems in undergrad and grad schools. I moved from insects to plants. And so anything that had bones was terrifying, and then it was anything that was an animal. I just didn't understand anymore. So my human anatomy is rough. And then this was kind of a funny little animation just that Matt Jones, the original creator of these slides, had added, where it's this idea of the stink bug that we saw. You got to worry about what's under the hood. It's not just the case that you're looking at. You're trying to think about what are those actual body segments. So we touched on this a little bit already, but exoskeletons are the hard outer skin and skeleton of an insect. So all of your bones are inside, all of their bones are outside. And they often, one of the ways that you can kind of target a lot of insects is that they will have these hard exoskeleton plates terminology is not important unless you want it to be. And those sclerites, or those plates, will kind of butt up to each other, and a lot of times there are these very thin spots where they're not totally protected, and those are good targets for things like dipple dust, or not, well, dipple dust, but also diatomaceous earth, right? Because it's a tiny little cutting thing, and so even if you have this fully protected hard insect, if you can get some of the cutting agent right in there, that's where you can start cutting them and you can cause drying out. If that's your thing. The main role of the exoskeleton is really provides support, and it contains the internal organs, and importantly, it must be shed for growth. So this is something we're going to get into when we talk more about the different types of metamorphosis and the different types of growth patterns that insects have, but the exoskeleton is a very limiting factor. And insects are extremely vulnerable during and after molting. So during those periods, they'll often hide, they'll kind of try to like lay low, because that's before that new exoskeleton hardens. So if you imagine this guy had this hard exoskeleton, he's emerging, and then he's going to have a period where he's a little bit soft. And he's got to harden back up, that exoskeleton's got to do its job, and so until then, he's going to lay low. And shed of exoskeletons is a possible sign of infestation, right? So if you see a bunch of exoskeletons hanging around, you know something just went down. It's a good time to assess whether you have a problem or not. Yeah.
Actually, how long does it take for that exoskeleton to harden?
I think it depends, but I mean, typically you see it like 12 to 24 hours. So, this is a weird example. But so, arthropods in general often have this kind of exoskeleton strategy, and so if you think about something even like shrimp, I keep tiny pet shrimp, and they shed their little exoskeletons, and they will lay low for a day, even though they're in water, just because it's like that's when they know. So I think it's typically that 12 to 24 hour period, but it might be different for different insects. Yeah.
Can insects close their spiracles when, like, they're in water?
Oh, like stomata?
Yeah.
I think so, because insects can survive some truly terrifying things for long periods of time.
Yeah.
So, for example, again, sorry, this is all anecdotal. I know that I've put a beetle in isopropyl alcohol in a -80 freezer for like 4 hours, and it came out and walked away.
Oh.
That was when I decided to move the plants. Yeah, it was above my pay grade.
I've been in my time done some unnecessarily cruel experiments with roaches.
Sure.
And I feel like I've always lived in places where they with me.
Who hasn't? Yeah.
And like they can survive for quite a while.
Yeah, I would imagine it's somehow related to the spiracles, but they definitely have mechanisms where they can just kind of close up shop for some period of time and wait it out. Okay, so in terms of the way that insects grow, and this is where exoskeletons become kind of a limiting factor, first we have gradual or incomplete metamorphosis. This is what things like grasshoppers, katydids, cockroaches go through. This is an assassin bug. So some of I think the true bugs often go through that. Yeah, bug is actually a specific subsection of bugs, but the true bugs go through this. And that's when the insect is born out of the egg as a larval nymph, right? And it's going to go through some number of stages called instars, where it just gets bigger. It doesn't drastically change form the way a caterpillar would to a butterfly. Instead, it's born like a little adult, and what will happen is it will be born, or it'll hatch, rather, sorry. It'll hatch, and so this says instar 1, don't worry about it. What I'm trying to demonstrate to you is that it will be able to reach a certain internal size inside of its exoskeleton, and then the exoskeleton becomes limiting. Has to shed that exoskeleton, and then it can reach a new internal size inside the next size of exoskeleton. It's going to go through that process a set number of times. Typically, insects have a set number of instars until it reaches its adult phase, and it's not going to molt after that. I think. Don't quote me on that. So again, you can see the exoskeleton is super helpful, super important, allows them to protect themselves, but is also limiting, and it's something that they really kind of have to plan around. This is kind of a more up close and personal example of that with this stink bug. Again, don't be confused that he looks like a little five-sided critter. He is an insect. As you can tell from this first stage all the way through to here, there's some changes in the shape, there's some changes in the coloring. Overall, though, it looks roughly similar. And so this is going to be, again, things like true bugs, cockroaches. A lot of insects go through this process, and this is kind of contrasted with complete metamorphosis. And so this is what you might be more used to from beetles, butterflies and moths, and dragonflies, lacewings, those sorts of things where they go through this full process and they totally change form. And so it's kind of nice to use a ladybug as an example of this because a lot of times people don't realize that this form they're seeing up here, that's actually a ladybug larva. Right, and they're kind of strange looking. And so what's going to happen is the adult ladybug will lay her eggs, it will hatch into the larva. Again, it'll go through a certain number of instars, larval instars. And so actually there will be this brief period where it looks almost like an incomplete or gradual metamorphosis because they'll just be sizing up. But then they'll reach a terminal size, they'll pupate, and they'll turn into adults. And so one of the things that's kind of really remarkable about this is that if you were to break open that pupae, it's like jelly in there, right? They've liquefied their body, they're reconstructing. And so the way that they're able to do that is that actually from the time that it's first hatched as a larvae, it has stem cells set aside in things, again, this does not matter, it's just like natural history for people keeping track at home. Stem cells set aside in areas called imaginal discs. So it has a set of stem cells set aside where its adult wing will be, that basically when it liquefies, those stem cell populations go to work creating those adult structures. And so it's kind of a really total rehashing of the body plan, which is just strange. That's how I got into insects. I broke up in caterpillar and I was like, what? Imaginal discs, yeah. And so that's kind of a big area of research for a lot of people is how you can have these stem cell populations that can give rise to totally different types of organs than you had in the juvenile. Another really cool thing about complete metamorphosis is so if we work through something like the pursley worm. So you start as an egg, this hatches into a first instar larvae, which is colored to look like bird poop, because that is its protection scheme. It'll go through a couple more stages, a couple more larval instars, where you can tell it's actually changing its coloring pretty drastically, just to be able to kind of camouflage and defend itself at different points when it's different sizes. This is the final coloring pattern it's going to land on. This is a fun fact that's not included in these slides, but the pupae, or the cocoon, as we would call it for a butterfly, will be green or brown. And that is actually genetically determined, and I think it's a case of selection where when there are a lot of green ones, the birds get really good at finding the green ones, and so the brown ones are more likely to survive. Then there are more brown ones, right? Then the birds get good at finding the brown ones, so the green ones survive. Right? So it's a sort of kind of balanced distinction between the two. Often, though, there are sort of biases for the seasons where you have to exist in that cocoon. So I think the brown ones are slightly more common going into winter, which would make sense because you're on the brown pit. Finally, you have the animal emerging as a full-fledged butterfly, and as you can see, right, these are very different animals. But that guy's genetic code had everything it needed to create those two totally different animals, which is pretty cool, actually, because, I mean, we just look like one thing and then we get bigger, right? There's no, like, massive restructuring.
Is that the one I sent you the video? Is that it kind of looks
It
like
might be. Yeah, and then this is, I forget if this is the male or the female. The opposite sex has, this blue is much more prominent, and it doesn't have this yellow, but it still has this kind of red dot right there.
What kind of blew my mind was I had these two parsley things, and the one had like 30 of these things.
Yeah.
And it was just going to town, and I'm fascinated. I'm taking the video. And when it has for about 5 minutes to do something, I came back.
Right,
I don't know where they're gone. And I didn't even touch the one next to it.
Yeah. Well, and that's a really good example, too, of just because something's eaten destroying your plants doesn't mean it's bad, right? I would personally like to have swallowtails, what these are going into, as much as I'd like to have parsley. It's a lot easier for me to like buy parsley than buy swallowtails.
Exactly.
Yeah, so,
That's what we identified as well.
yeah, and so it could completely defoliate it and I'd be pleased. I mean, it's the same thing like if you plant milkweed for monarchs, your goal is actually basically to destroy your milkweed. It will just be chaos, it'll be stripped, there'll just be bug poop everywhere. But that's how you know that you were successful. So it's worth thinking about too kind of what your end goal actually is. If your end goal is to have a lot of beautiful butterflies, you're gonna have caterpillar damage. And that's just the sign that you're moving in the right direction. So, kind of looking at larvae, so this is the, we're really talking about those kind of early caterpillar-y larvae type stages of complete metamorphosis. They can vary wildly kind of within orders. So you have maggots, which are the larval form of flies. Flies also go through a complete metamorphosis. If you ever keep compost on your kitchen countertop, you can often find that kind of pupae around. Never has happened to me. You can see caterpillars vary. You have these very, like the woolly bear type ones. You have the ones that you would see on kind of like cabbage. You have tobacco or tomato hornworm, which is one we'll see a lot of in this area. And this is kind of more the typical structure for grubs, which are larvae of Coleoptera or beetles. And so they, in some ways, are a little bit more similar to caterpillars than they are to maggots, in that they have these hard little head cases and then kind of fleshy bodies, whereas maggots are just kind of, I don't know, ugly. And so, just another fun fact, the way that the caterpillars know, or larvae know when it's time to molt, like when they reach their total size. Because remember, if you're a hard-bodied insect, the way you know to molt is your type. If you're a fleshy insect, how do you know when to molt? It's actually that head capsule. That is the only tight part of the body, and when that reaches a certain tightness, that's what sends the signal to the rest of the insect, like, move on, next slide up.
It's the woolly caterpillar, the one that if you touch it'll sting you. Because I had an issue last year and I didn't know what, but it was a caterpillar and it was black and it really burned my finger.
I have poked them a lot. I've never had problems with them, but it might be kind of an individual. I don't know. I have a tendency to get in there, but. So when we think about how insects impact us and how they impact our gardening especially, it's important to think about the number of generations per year. And so this will become kind of apparent in a minute. But so a generation is the life cycle of an insect. So it's from egg to adult, right? So it's that egg being laid, hatching, going through whatever metamorphosis process, turning into an adult. And then when the next egg hatches, that's the next generation starting. And so a lot of insects in the north will have kind of a univoltine or one brood per year strategy, and then down here they can actually hit 2 or 3 per year, which makes things like squash borers more terrifying here than they are in the north, because the squash borers can get 2+ generations per year, and so your squash are just never safe, right? Like there's no we got them through that period or plant after that period. It's like no, they're coming. And this is just kind of important to think about in terms of targeting different pests, because if you know that you need to be targeting at the larval stage, it's important to know when does the larval stage occur during the year. Is it always really, really set, or are they running on kind of these different schedules and you're almost capturing different generations? That's the other thing too, right? If you have an insect that has 2 or 3 generations per year, and you're very diligent about getting out when you've heard that the larval stage is, well, that was once, right? Do it again, keep doing it. Yeah, insects are awesome. And some of our most destructive pests are things where the generations are overlapping. And we have a mild enough climate that does happen here, where things can kind of just be almost running continuously. So, another thing to think about, this is actually quite important, especially in terms of identifying damage from insects and who the culprit might be, is host specificity. So we talked about monarchs earlier, right? Where monarchs are only going to be feeding really on milkweed. So, right, you can have a milkweed that is totally swarmed with monarch caterpillars, So some of the things, so most insects feed on narrow range of host plants, and few insects will spread to everything. That's really, really uncommon. Oftentimes you'll even see, we'll go over one bug later, the kudzu bug. It likes kudzu. You'll see swarms of it on other plants though. And it's not a problem because it's not kudzu, but it will look very upsetting. So the way to think about this is that host specificity can vary between life stages, and often if an insect can do one type of plant, it might be able to do a very closely related species, right? So we think about tobacco and tomato hornworm. You might see those on each other, and that's because the plants themselves are closely related. So there are some generalists. So there are some insects that just are out to get us, and they don't really care. This is going to include things like grasshoppers, Japanese beetles, some aphids, and luckily for us, predators. So the predator insects tend to be somewhat more open to what they're preying on. So that's actually very, very lucky that there actually really aren't that many generalist herbivores, things that are going to be eating our plants. There are a good number of generalist predators. So that's like finally some good news. And so then in terms of, you see damage on your plant, what are you going to do about it? You got to first know who was probably responsible for the damage, or at least what type of insect was responsible for the damage. And the main way that we as gardeners can separate that out is by thinking about the different ways that insects feed. That's really kind of your major thing. Different types of feeding are related to different specific types of insects and cause obvious different signs of damage. So you have mostly you're going to have feeding damage, and we'll talk about that more specifically. You can have nesting and egg-laying damage, and also a number of the insects, especially the ones that pierce and suck either xylem or phloem, they're kind of problematic in that they're taking your plant's nutrients. They can be very problematic in that they can be like mosquitoes, right? They're just little disease vectors moving from plant to plant, spreading things along the way. Now we're coming to kind of the differences between signs and symptoms. And this is a good way to think about, again, how you figure out what insect is responsible for damage. So signs are going to be evidence of pest presence, right? So it could be things like excretions, secretions, and body parts. I love body parts. But so this is going to be things like, this is hard to see, but a lot of times, so here's a little caterpillar, he's all rolled up in a little ball. He's on what looks like some sort of cabbage leaf. And then you'll see these little black dots next to him. The euphemistic word for that is frass. That is insect poop. And so oftentimes you will see kind of all this chewing damage, especially through things like cabbages or other kind of leafy greens. And then you'll see all these black droppings everywhere. And you know that was a caterpillar. It's pretty clear. Another sign you can see sometimes is galls. Galls are really interesting because it's where the insect has basically induced a sort of more uncontrolled growth form in the plant to give its offspring a lot of wonderful, nutritious things to eat. So I always think that's kind of cool because it's a case of an insect actually kind of like triggering a different growth form. Yeah.
So in that picture and also in the book, galls are red. Are they?
They can be different colors.
Okay, it just happens. And
Yeah.
The only two pictures I saw were red, so I was trying to figure out.
Yeah, a lot of times they're red-brown just because they, it's a really strange growth form. The plant's not producing chlorophyll in there quite properly. It's just kind of like it's,
Because I feel like
It's
I've
like
seen
cancer.
that before, but not red, so that's why I was asking.
yeah, right, and they can be different colors. They can definitely be different colors. Other signs, silk webbing, cast skins is what they mean by body parts. Again, that's the idea of those exoskeletons flying around. Slime trails and honeydew. And we'll cover honeydew a little bit more in depth later in the second set of slides, just because that's an important one to think about with a lot of different insects. So signs can be contrasted with symptoms, which are plant response to pest damage. So sign is an actual evidence of plant presence. Symptom is what the plant's doing in response to that plant. So this is where you're going to see things like distorted growth, disease symptoms, and feeding damage. Distorted growth we'll talk about a little bit more in depth, but a lot of times you'll see leaves curling and twisting and kind of all these different strange responses because they're not able to transport nutrients and water properly in response to the insect damage. is where it gets important. Insect mouthparts. So we have, in terms of damage causing, we have two major ones we're concerned about. It's going to be chewing and piercing or sucking. There are also insects with sponging mouthparts, so that's going to be like your flies, you know, that kind of go around doing this thing, right, all the time. And also siphoning or chewing/lapping mouthparts. And so that's going to be more like what you think about with a bee or with a butterfly and its proboscis, where it's actually going in a sort of targeted sense to get nectar or other kind of rewards from the flower. So chewing mouthparts. So at the top left, you'll see that is that's a beetle. He's got these kind of really hard chewing little mouthparts, and he's going to go through and do all this sort of chewing damage. That's contrasted with this is actually a rejuvenate allele bug. This is a predator. This is not a guy I would ever be worried about seeing on my plants. I might not poke him, but I wouldn't be worried about seeing him. But so he's a really, really good example, though, of this whole structure right here. It's called the rostrum. It's a piercing, sucking mouthpart, and what he is going to do is he's going to go find other insects and basically pierce them and suck them. And so that's great when he does that, but there's a lot of little insects that are going to do that to our plants as well. Just really drive it home. It's the chewing versus the piercing, sucking that you predominantly have to worry about, and a lot of what you're going to see damage from.
What did you say the name of that?
Rostrum, R-O-S-T-R-U. Rejuvenate. Oh, it's a wheel bug. Like a sassy bug. So you said what else is that?
The chewers are the ones that we should worry about.
Chewing or piercing and sucking. Because if you think about like stippling damage, that's all piercing and sucking. Okay. So for chewing mouthparts, we're going to have a lot of leaf eaters. So you're going to have things like caterpillars, beetles, both the adults and the larvae can cause damage. In contrast with the caterpillars, where the butterflies are not causing the same damage that the caterpillars are causing, right? Even though it's the same individual, just at different life stages. We're going to have grasshoppers. I'm sure you've seen that sort of damage. And again, the signs are going to be the chew marks in the holes, the frass, and the webbing. Frass is always kind of a funny one to look for, especially if you have something like a tomato plant that was really infested with tomato hornworm. The frass is big, it's obvious. It's almost amusing. It's like such an over-the-top sort of caterpillar. So for chewing mouthparts, that's the sort of damage that can happen on the top of the leaf. We also have damage that can happen actually within the leaf. So the insect is able to get in between the two outer layers and cause damage because it really wants those really succulent inner cells. It doesn't want the sort of harder protected outer cells of the leaf. So this is things like leaf miners. And again, they're eating, the mesophyll cells are the middle cells. And they don't want those harder protective cells. Because as you can imagine, the plant has cells on each side of the leaf that are just meant to defend and be kind of tough like our skin, right? They'd rather go for guts. And this is going to be usually fly larvae. There are other things that can cause this damage, but typically if you see it, it's going to be fly larvae. And the damage, although very interesting looking, is actually usually kind of minor. It looks dramatic, it looks worse than it is. They're not going to go through and kind of like strip a plant the way something that's eating the leaves might. You're also going to have these skeletonizers. This is another sort of damage that is mostly just very interesting looking. What they're really looking for is they're looking for the non-vascular tissue of the plant. So they're going to be eating all the cells between the veins. So you remember last week Charlotte showed us, how you have the different vein structures just the way we do, and so they're going for kind of all the space in between. And so what ends up is the skeleton of the leaf remains, and you get this kind of lace-like appearance. So you have more types of chewers because they can wreak all sorts of havoc. You also have borers. We have a number of borers in this area that especially can really take down trees. We'll talk about those more when we kind of do an overview of insects of the area. Like I mentioned earlier, the squash vine borer is one that's particularly nasty. You'll have a wonderful, beautiful, big, healthy squash plant. Next day you come back, it's just wilted, and there's nothing you can do about it. Like, just tear it out and get it off the property.
First one small, what does that say?
So we have the southern pine beetle, and that's a borer in bark, and then we have squash vine borer, and then these tiny little dots are boring on a tree branch. But Yeah. So this is going to be a lot of beetle and moth larvae, and they feed under the bark of the stem and on wood tissue. And some of the signs and symptoms are going to be sawdust, holes, tunnels, secondary disease, and oftentimes there is no treatment. Get the plant out, get it off the property. Don't mess with it, because the thing you want to be aware of with this sort of damage is that what you're looking at is predominantly actually the damage from the larvae. And so if you were to just cut that plant down or put it on your compost bin, the larvae now has plenty of time to go ahead and develop, and it is emerging in the middle of your property, right? And so you kind of just want these things out or destroyed. Yes.
Could you give a couple of examples of skeleton spiders, or are they also usually fly larvae?
I don't know. I'm sorry. Yeah, I can look it up. Let me look it up and get back to you. Yeah, no, I got it.
Does the skeleton pattern allow the leaf to kind of regenerate? Is it,
No, yeah, so that's something to kind of be aware of with plants versus animals, and this is a distinction that took me kind of a long time to really appreciate, is that plants, once they grow, they've kind of grown at that point because their cells, the way a plant cell works, right, is it's got this really hard cell wall, as opposed to our cells that can kind of scoot around and move even within our bodies. If a plant puts a cell here, the only places it can now put cells are on the sides. And so if this cell is destroyed, that growth is kind of done. It can't move cells in to fix that the way that we might be able to. It can't kind of grow cells in strange shapes to fill strange spaces. It's got these much more confined ways of growing than we do. It's just because actually plants and animals developed multicellularity as totally independent things, and so they act really differently.
So is that one reason that a plant with damage, that particular branch will die and drop off quickly to save the rest of the plant?
Sometimes they can do that. I mean, that's even like what we were hearing last week with like the excision layers on leaves, where you get to this point where you're just like, no, just be done with it, like, move on. Yeah.
They can grow new leaves though, right?
They can grow new leaves, but like once that structure is set up, like all the vascular structure is set up, and then you go through and take parts out, you need a new leaf.
Right.
You're not going to fix that little leaf with the damage.
Because in 2013, those of us who have a lot of oak trees had a really nasty infestation of cankerworms.
Yeah.
Yeah.
Ugh.
That
Yeah.
defoliated the trees in some cases like 80%.
Right. But they leaf out again. And that's actually the real problem with cankerworms, is that if you have nasty infestations year after year, you force the tree to leaf out twice each year,
Yeah.
and that's a lot of energy, right? And that will eventually take it down.
Yep.
So, moving on to piercing, sucking mouthpart damage. So, this is a case where you can have basically either rostrum or proboscis penetrate to extract fluids. This can cause discoloration, so remove cells containing chlorophyll. Stippling, tiny dots that can progress to leaf bronzing or yellowing, or distortion. And so stippling is a pattern that's really good to kind of be aware of. It's what you're going to see down here, and I'm sure we've all seen it in our gardens, where you kind of look at the leaf and it's almost like someone took a brush and just lightly applied a lighter color. And I can try and show some bigger pictures of that. But so it's very indicative of things like Azalea lesbos, I think is the name of them. But so there's a number of different stipplers that can cause that kind of problem. And that's because they have these piercing, sucking mouthparts, and they're kind of going through in a targeted way and just removing tissue and fluids that you wanted. Honeydew is something we're going to hit on a couple times just because it's actually pretty interesting. So if we think about aphids especially, they tap into the phloem. I personally always remember that phloem is food. And so that's how I know it's the nutritive tissue as opposed to the xylem, which is the water tissue, or the water vascular tissue. So the aphids are going to tap into the phloem and they're pulling sugars. And so what they give off out the back is actually just sugar water, more or less, called honeydew. And this is really an interesting thing, but not that helpful of a thing, is how I would put it, because it can attract ants and wasps. There are a number of ants that actually have very close relationships with aphids because they can basically farm them, because the aphids are little like sugar factories, right? And so you can the ants will do all sorts of charming things like moving the aphids to the underside of the leaf. They know rain is coming, or So which is pretty cool. But if you want a plant covered in ants and wasps. So the other real problem though is that even if you don't attract ants and wasps, it can be a really, really good breeding ground for city mold. This is because if you imagine what you've done is you've taken a healthy plant tissue and you've just kind of coated it in sugar, right? And that's a really good environment for all sorts of nasty things to take out. So city mold is a fungus that grows on honeydew. It blocks the sunlight, and it can be kind of manually removed, and that's the way to open it back up. You can also use horticultural oil or other things that will kind of suffocate the aphids. But just be aware that a lot of times if you're seeing this sort of city mold kind of black covering that you can kind of wipe off with your finger, this looks like you have a mold problem. You have a honeydew problem, right? There is some insect on there that's actually causing that.
And also the ants, I've seen this in crepe myrtles. The ants are marching up and down to herd the aphids around, so they trap the honeydew around, and the city mold just grows up the entire trunk
Yeah,
of the crepe myrtle.
it's terrible. I mean, it's cool, but it's terrible.
It's ladies.
What?
It's ladies.
Yeah, although it's hard because like a lot of the studies they do with that, it feels good to release a bunch of lake bugs.
They don't eat the aphids.
They
You got, once the food source runs out.
Yeah, I mean, you have this like great like releasing doves moment. But, like,
Just eat a few dead aphids, girls.
Okay, so other ways that insects can cause damage. We have egg laying, also called ovipositing. So this is kind of going back again to that. Oh, sorry.
Question.
Yeah.
Are all of the disease, or the majority of the disease that you see in the trees caused by insects?
Let me think this through for a minute. I will tell you that a lot of the things that I see coming are actually caused by insects. And they certainly might be spread by insects. But, so, okay, I have kind of a tricky answer, and that's, to be perfectly honest with you, most of the diseases that you see on plants in general are actually because the plants are weak. So if you have a plant that's healthy and strong, for the most part, it can defend itself. And so the insects might be spreading the diseases around for sure, but I often like to think, so if I have a plant that's harboring city mold, step back. It's actually probably a honeydew problem. Step back. Why are the aphids attacking this plant? Like, what is going on with this plant that makes it more susceptible? Because if all of its defenses are really going full guns, it's a little bit harder for it to attack. So, I think a lot of the diseases are spread by insects, but I think that ultimately your most base problem might be even an abiotic problem. Maybe there's not good drainage, maybe the site is not quite right, maybe it's not getting enough sun, that's put it in a weakened state. We don't have that many insects in this area that are just going to attack healthy plants. We have some, which is terrifying, but not most.
There can definitely be fungal infections as well.
Right. And it's all stuff though that I think like the insects flying from plant to plant, that never helps, right? That's always like, but
So that's really interesting. So an aphid infestation is basically telling you
it's
there's something already inherently wrong.
I often try to kind of approach it from that perspective of like, it's one thing, okay, we got to take care of the aphids right now, because the aphids are not helping. But it's worth stepping back and trying to have a thought about what's going on with my plant care and with my kind of like garden husbandry that's allowing that to happen. Maybe it's not you, but in my garden, it's typically me.
So like, the other side of the coin, like if a plant is covering aphids, that's doing great, that would be a sign of like the abiotic stuff is, yeah, who knows?
Yeah, like the
I
aphid
see
gods
that
are
more
going
often
on you.
than not,
Yeah.
you know, it's like,
And I would still try to
Yeah.
move them along. Good questions. So in terms of egg laying and ovipositing, this is where a lot of times you see that gall formation, because the gall is actually a structure that the egg laying insect has kind of induced to have food for the offspring. You'll also see twig girdlers. So it's, I just noticed. So it's hard to see, but so this is a longhorn beetle. And there are forms of longhorn beetle around here that are twig girdlers, and so this is almost impossible to see, but these slides will be available online. But there's a beetle here. This is an antennae. This is an antennae. It's perfectly blending in with the twig, and what it does is it kind of girdles right around the twig to create kind of almost like a weak twig that its offspring can live in better. And so what you'll do is you'll go out into the yard and you'll find just these like almost like perfectly cut little twigs all around. And that's a sign that you got to get those out, right? That is damage from insects, and I would just get it out. And so pecans are one, especially where you can see this. And so you can see this is a little bit more of an obvious example, right? And so what's going to happen then is this female is going to girdle that twig, and then this is actually the larval beetle right here living in the twig. And we definitely get those around here. So as we've kind of covered, there are a number of different ways that insects can damage plants. One of the major ways is disease transmission. So 200 plus plant diseases spread by insect vectors. So this kind of goes back to your question a little bit. A lot of them. Mostly viruses, but also some bacteria and some fungi. They're often directly transmitted by the insect body. So this is that feeding idea of like, if you go through and you just stick your little piercer right into a bunch of different plants and suck up some food, that's a really good way to transmit. And they can also cause indirect spread just by causing wounds. So even if you didn't spread anything, you're just going around wildly wounding trees, right? And those all become spots where the tree can get infected. And so this is kind of where we get back to this idea of, okay, so I just told you a bunch of terrifying stories about the way that insects can hurt your plants, but from a gardening perspective, it's really important to think about how serious is the problem really. And this is going to be something we're going to kind of touch on throughout the entirety of this class series, is this idea of integrated pest management. And that's an idea that what you want to do is you want to know how serious your problem really is, kind of what's your tolerable level of pest. So your level of pest is not zero, right? That's not realistic. It's not going to happen. Your level of pest is what you can tolerate, and how do you keep it below that using strategies like good planting, good air, keeping an eye on infestations, even manual removal, so that you don't go above that tolerable level. And only kind of when you start really ratcheting up into problems, do you start thinking about chemical interventions. And so how serious is the pest problem? It can depend on a number of things, including the age or size of the plant. So how much of the plant is really affected? And younger plants are more vulnerable. But if you have a big plant that's mature and healthy and doing a good job, and you're only seeing this damage on, say you have a big azalea, you got stippling on 10% of the leaves. It's big, it's healthy. You're okay. Just look at a different plant for a while. You know, it's fine. You don't need to whip out the big guns at that point. Although do know that younger plants are more vulnerable, and that's the stage where it's worth thinking about keeping an eye on things just to make sure they're okay. And especially if you only have a small number of younger plants, physical removal of insects is not a bad strategy. It's also important to think about which part of the plants are attacked. So leaves are not that serious. So if you think about something like the willow oaks that get the cankerworms, it's a big problem when it happens year after year after year after year, and that's what we've got in this area sometimes. And it's because it's causing them to leaf out so many times that it's taking a lot of energy reserves. However, that's also a really good indicator that actually you can have basically all your leaves eaten one year, produce an entire second set, and it's okay. Right? That's really different than stems being attacked. Stems are where you need to be a little bit more wary. So contrast that with the example of the squash vine borer, where that thing goes in, lays an egg right at the very base of the stem. Well, that's it. Just throw the plant away. Like, just move on, right? And that's because that sort of disruptive stem damage it can be very serious. And so this is something we just talked about too, where it's also if the plants are overall quite healthy and just start to have a problem. First off, I would take that as a cue to see if there are other things that might be affecting the plants. But do know that those healthy, resilient plants are going to be more able to bounce back. Right? It's the same idea if you get a cold but you're doing fine, just keep on moving. Or even if you get the flu but you're doing fine, just keep on moving, you're going to bounce back if you're generally healthy. If you get the flu and you're a baby or a person with a compromised immune system, that's a really different story. This kind of goes back to the idea, something Charlotte talked about last week, is it an ornamental or an edible plant? We are asking edible plants to take a lot of resources and put them into structures that are going to be removed, right? So they're already putting a lot of their energy into things like tomatoes and other things that are not just about their personal health and growth. So edible plants can be a lot more susceptible than ornamental plants, right? An ornamental plant just has to kind of keep itself going and incidentally makes some seeds. An edible plant is making these big structures that we're taking off, so already you can tell a lot of its energy is not being put into defense. And how long do you think the pest will persist? So do you think it'll persist over a few weeks or a few months? And this is a good thing about, we're going to be talking about ways of IDing some of the different pests in this area and some of our major ones. But it's really important to kind of try and get a rough idea of what you're working with, right? Because if you're worried about caterpillars and winter's about to hit, that's a self-solving problem for the most part, right? But if it's April, I might plan differently. So we'll be talking more about this when we cover integrated pest management later in the course, but I just kind of wanted to start introducing these ideas of it's not just that you're just trying to whack everything back at all times. It's about setting reasonable levels and also kind of knowing specifically what you're dealing with to know how to approach it in a targeting manner with kind of the least intervention possible. A little bit of keeping track of your plants is gonna get you pretty far. So with that, let's take it like a 2-minute stretch break. Just skip, move it.
So I have a very difficult problem with the squash boards. To get rid of them, what do you do? I used to pull it up and take it to the compost pile. I used to take it to the compost pile outside the property. Now I put it in a black plastic bag and take it to the dump. Is that what I'm saying?
Yes, that's right. They are results are super good. So it doesn't matter if it's yeah. Oh, yeah.
No.